Put your big boy and big girl pants on. Piecewise function time. Let's get it. So, ignore this up here. I'm not good at editing. I couldn't get rid of it. This I rewrote. It's a better one to look at. This is what a piecewise function looks like. Essentially, what we're going to be doing is seeing a graph that has two different types of behavior, and there's essentially a wall where the behaviors are separated. So here's how it looks. F of x exists, and it behaves x minus 2 if our x values are less than or equal to 3. But if x is greater than 3, it behaves negative 2x plus 1. So we're essentially looking at two functions combined to make one bigger function. So here's my steps to guaranteeing you're going to get the graph correctly. Step 1, find the wall. The wall is where our behaviors change, and we need to decide what it looks like to the right and what it looks like to the left of the wall. So here's where we look first, the inequality. If you'll notice, our inequality tells us where the wall is. They're telling us we have one behavior all the way up to 3. But once x is 3, it changes. So everybody understand that 3 on the x is where my wall is. So first thing I'm going to do is I'm going to go to my graph. I'm going to find where my x value is 3, and I make my wall there. I'm going to make it dotted because essentially this is not a part of my graph, but it is going to help me a tremendous amount when I actually go and do my graph. Hopefully that brown's coming through. So now that I know where my wall is, I need to find my wall points for each of these. So I'm going to treat these like two different equations. I have y equals x minus 2, and I'm going to deal with that one first. So what I need to understand is this is exactly how my graph behaves and what it'll look like all the way up until I have x values that equal 3 or more. So I need to find out where I will be on the wall. So I call this step finding the wall point. So if you'll notice, I hit my wall at 3, so I need to find out where is this at when my x value is 3. I replace my x with 3 because that's where the wall is. So you can see we'll get a y value of 1. So my first behavior will have a wall point of 3, 1. That's where our first behavior will be when it meets the wall. Now, before I plot it, I need to look at the inequality. Notice that this first behavior is less than or equal to 3. So when this meets the wall, it will be a solid circle because it's equal to, it's included. So I go to 3, 1. There's my wall point for my first behavior. Now I just look at how it was behaving. Remember y equals mx plus b, slope and y-intercept? Well, all I need now is the slope because I have a point. My slope is 1. Now, the traditional way to move with a positive slope is up and right. You cannot do that. You can't go in to the area where it doesn't belong. It can go up to 3, but not beyond it. So instead of going up and right, we do the inverse, down and left. How many points to draw a line? 2, we got it. Draw your line. Beautiful. Now, I have to deal with my second piece of the function. Get it? Piecewise. You'll laugh later. Okay, y equals negative 2x plus 1. Now they share the same wall. So I need to find out where my second function is on the wall. So I'm finding its wall point. Well, the wall hasn't changed, so my x value I'm replacing doesn't change. It's negative 2 times 3 again, plus 1. Again, all I'm doing is finding my wall point. I get a negative 6 plus 1, so my y value is negative 5. So my second behavior's wall point is 3, negative 5. That is where this function will start on the wall. But again, I have to look at the inequality. This is not equal to. So it will be an open circle at 3, negative 5. I have 1 point. I need to see how it's behaving. This has a negative 2 slope. So I can't go left. I'm not allowed to. This starts beyond 3. So I go down 2 and right 1, and now I have my slope, and I can draw my line for the second behavior. Okay, that is the graph of our piecewise function here. Let's go through the steps one more time. First, find the wall. By doing that, you look at the inequality. Inequality tells you where the behaviors will change. Wherever that change occurs is where your wall should. Now, I take my first behavior and I use my wall to find my wall point. We replaced x with the wall value of 3. We get a y value of 1. So we started our wall point at 3, 1. Once you have your wall point, look at how your behavior moves. I have a slope of 1, so instead of going to the right, because I was not allowed, I went down and left, and there's my behavior for the first piece. And then we just repeated. We already knew the wall was 3, so I found my wall point by plugging in 3. My second behavior starts at 3, -5. Look at how that behavior is moving. Slope of -2, so I go down 2 and right 1. Now the last thing we have to do is domain and range. Domain being the x values, range being the y values. We'll take a look at your x's. X's left and right. Does it ever stop going left? No. Now we have this interesting exchange here, but notice no value is left out. While this is an open circle at 3, it's a closed circle at 3. Essentially think of it as if you're doing track and field and you hand off the baton. Baton never dropped, hopefully, don't ask Team America, but hopefully the baton never dropped, and so no x value is left out, and it picks it up and continues going to the right. So for that reason, no values are left out. Our domain in interval notation is -infinity to infinity. Now, your range, your y values. Now this one varies a lot from function to function. If you'll take a look, range being y values up and down, when you do interval notation, you want to look at smallest to largest value. Well, both of these are heading down south, okay? So they will not stop as they approach -infinity. That's the good news. So you know your range starts at -infinity. But how high does it get? Now, while this one only climbs to -5, the other one climbs to 1. Now, they are both represented the same function, so the highest value on this graph is 1. Now, bracket or parenthesis, it's a closed circle, so it is a bracket. If that would have been open, we would have had another parenthesis. That's a quick rundown of how to view, attack, graph a piecewise function, and how to get the domain and range based off that graph. Hope you enjoyed. We'll see you soon.